Hello students, hope you understood the concept of perimeter that we discussed in our last video clearly. So in this video, we will start with the concept of area. So this is from chapter 6 of your 9th grade NCERT maths book, Ganita Manjari. Okay, so let's start with learning about area. So for a two-dimensional figure or a figure on a plane surface, what is the concept of area mean? For a plane figure or a two-dimensional figure, the area is the amount of space occupied by the plane figure. For example, if I draw here this rectangle, then all this green color inside this rectangle forms the area of the rectangle, right? So this is basically the area of a plane figure. Okay. Now, how do we measure the area? Okay. Measurement of area. So measurement of area is done in terms of square units. Okay. So for example, I will take a square. When I take a square, this is a square, okay, and I say this length of the square length of the side of the square is A. Maybe I'll just delete it. And this is A, right? So this is a square. Side is A. Then what will be the area of the square? A square. Right? So this is something which you have learned in your lower grades as well. Similarly, you have a rectangle. For a rectangle, if you have for example, I'll consider the length of the rectangle as A and the width is B. Okay, so this length is A, this width is B. So we'll say rectangle length A. Okay, I missed to mention here, we should always mention the unit. So area is always in terms of square units, right? As I mentioned here, right, that measurement of area is always in terms of square units. So this unit here can be centimeter, it can be meter, it can be kilometer, it can be any unit of length. Okay, so for rectangle area, so length is A and we'll say breadth is B. So what will be the area? Area of rectangle will be A into B, right? So this is also something which you have already learned in your earlier grades. Again, I didn't mention the unit, which is really, really important, right? So let's say it is square units. Okay. So next, what we can see? We can see the area of a parallelogram. So we can just try making a parallelogram. Like this, can I rotate it? I think I should be able to. Okay, this is more like a kite. So I'll go ahead and draw a parallelogram myself. So this becomes our parallelogram, and then I'll say this, the base of the parallelogram. What is it? This base is, we can say B. Okay. And then what I'll do is I'll draw a perpendicular from one of its vertices. So this is 90 degree. Let's name this parallelogram A, B, C, and D. Right? So what is the area of this parallelogram? Parallelogram. It has base is B, and this height is h, small h, right? Height is h. So what will be the area of the parallelogram? This will be parallelogram. It was correct. Oh, I had missed it. So area of parallelogram will be B into H. Or we can say BH, or we can just say here square units. Right? So now how did we arrive? If you remember from your previous class, I think you studied this in grade 8. So what we can do is we can just, this is H, and I draw a line from D, another line perpendicular from D to the base AB, right? And I extend this AB. Okay, now this is again, and similarly I draw a perpendicular line from C to the base AB. Now from the figure you can see very clearly, right? This is also H. This is also H. And this line, if we take from this here to here, this is B, right? So this B and H, right? They are forming a length and width of a rectangle. So when we have extended it, right, it is the height is anyway the same, because we are drawing from a vertex to the base of the parallelogram, both sides. And the distance here, this distance is same as this distance. this distance, right? So that is where, if we are excluding this distance, we are including that distance here. So overall, it becomes B into H. That is how the area of the parallelogram is derived. Now, similarly, you also had studied about area of a triangle. So let's start with a right angle triangle first. So triangle. Okay. So for triangle, I'll first draw a right angle triangle. This is because this is the simplest. When we see how the area is calculated, it is the simplest for this right angle triangle. And this is A, this is B, and this is C. Okay, so I took first here right angled triangle. This is A, B, C. So what do we see here? Right now, we don't see anything. But then if you draw this perpendicular from here, right, and you extend this, so what do you see? The BC, length BC is equal to, I'll call it D. So length BC is equal to length AD and AB is equal to CD. So for example, if we say here that this base of the triangle is of length B, or I'll make it small, and the height of this height is H. So in that case, this area of A, B, C, D will be base into height. Now if you see, this AC is the diagonal dividing this. Here it is looking like square, but in a real world scenario, it can also be a rectangle. So we'll say dividing the figure into two equal halves. So which means our area of triangle ABC will be half of the area of the rectangle or whatever, rectangle or square that is formed. Right here, we are saying B is not equal to H. So this is going to be a rectangle, right? So then what will be then in that case? The area of ABC will be, it will be half into B into H square units, right? Because this area of ABCD was B into H. So this area of triangle ABC will be half of B into H. So this forms the formula for the area of a triangle. Okay. Now next we took a right angle triangle, right? So someone may say, okay, what about the acute angle triangle? What about obtuse angle triangle? So let's take the further cases. Let's draw a acute angle triangle. So this is my acute angle triangle. I hope you all remember what is an acute angle triangle. All angles should be less than 90 degree for a acute angle triangle. So this is my acute angled triangle. Here I took right angle triangle. Now I'll take acute angled triangle. And what is the triangle? Maybe C, right? So as usual, what I'll do is, first I'll draw the altitude, which is the perpendicular from one of the vertex to the base. Here my vertex is A and my base is BC. So this is my altitude of the triangle. Okay, and this is the base B and this is H height. Okay, now what I'll do is, as I did for other case, I'll just draw a perpendicular from here. Okay, and I'll extend A. So what will this be? Again, this is going to be H, right? And we'll assume here this B is the total distance, right? But for BC. So I'll just assume that this part, for example, I'll call, where this perpendicular line is meeting the base BC. Let me call it, what should I call? D. So AD, I can say that AD is perpendicular to BC. Okay. And I'll say that this BD is B1. This is of length B1 and this is of length B2. So what is happening is this B1 plus B2, B1 plus B2 is equal to B. Okay. And height is H. So now if we consider this, I'll call it E. And if we consider it AC, ADCE, this is H into B2, right? This entire thing will be H into B2. And just like here we saw, right, this is now forming a right angle triangle. ADC is a right angle triangle. ABC is this triangle. ADC is a right angled triangle. We already proved here, right, that area of a right angle triangle is half of B into H. So we can say, we can use that same thing. Area is equal to half of, what is the base here? Base here is, maybe I'll just write it down here. Base is B2 and what is the height? H. Okay. Similarly, what we can do is, we can extend this side. Just like we did AE, we can extend on this side as well, right? Both this. right? And what do we see here? We see here a triangle, uh, triangle ABD is right angle triangle, and we just figured out area of a right angle triangle is, what is it? It's half of base into height. So this will be 1 by 2 into B1 into H. Okay, so what will be the total area? Total area of triangle ABC will be area of triangle ABD plus area of triangle ADC. So which is half of ABD is B1 into H, and this one is plus half of B2 into H, right? And I do a summation here because this is a, I can take 1 by 2 outside, I can take H outside, and then I'll do a B1 plus B2. So already I saw, right, what is B1 plus B2? That is B. So this becomes 1 by 2 into H, or I can say B first I'll write, and then H, because that is the standard convention. Square units. So we have proved here that for acute angle triangle also the area is the same, half of base into height. Similarly, we can prove for obtuse angle triangle. So I hope you also remember the obtuse angle triangle. What is it? That is the triangle where at least, not at least, where exactly one angle is more than 90 degree. Okay, so this is my obtuse angle. I'll just call it A, B, and C. Okay, so this base, this is the base, and we can draw a height from any of the three vertices. This is the base. So what we'll draw is, I'll draw a height from A. Okay, so this is the height. Now to meet the base, because this is like, obtuse angle triangle. So that is why this altitude is coming outside of B. Now you can also draw, if you want, an altitude from B to AC. Okay, that is also going to give you the same. In this case, our base will be, because vertex is B, our base will be AC. So we will call B the length of B. AC is equal to length of B, and this is our altitude, and it is very similar to what we did for this acute angle triangle, right? Because we'll have two triangles here, ABD, in right, and this is a right angle triangle, so it will be half of base into height. So this is my B, and this is going to be my H. And I'll remove this. I'll show you in another figure how if we draw from A to BC also, it can give you the same thing, right? So This is our obtuse angle triangle. Obtuse angled triangle ABC. Here, what is the base? Base is AC is equal to B, and height is BD, which is H. And then we can say that it is the sum of, we can say area of triangle ABC is equal to area of right angle triangle, right triangle ABD plus area of right triangle BCD, right? So here we can say right triangle, if we are suppose breaking it into again, two, we call it, this is B1 and we call this B2, right? So it will be the same as above, half of B1 into H plus half of B2 into H. Take out the common things. Common things here are half H, and then what is remaining is B1 plus B2. This gives us B1 plus B2 we know already, that is equal to B. So this will give us half of B into H. Again, for obtuse angle triangle also, it's the same, half of B into H. So basically it is for any triangle, whether it is obtuse, whether it's a right angle triangle, whether it is an obtuse angle triangle, for any triangle, it's going to be half of base into height. Okay, and then I was telling you that if we draw the perpendicular from A, how will that look like? If we prove using that, because that perpendicular is coming outside, right? So what I'll do is, I'll extend this, and then this is my height. If I'm drawing it from A, this is going to be my height, right? So what we can do here is similar to that. I'll just extend it, this point parallel to this height, and I'll extend this one also and keep extending it till the end of this, and I can draw another perpendicular line, right? So what we see here, this is H, right? Height of the triangle. This is H again because it is same. We draw a parallel line, right? So that is why it's the same, and this is also the same. Now our base was B, so this is B, base of the triangle. I will draw an arrow here and arrow here to show what is the length actually of B. Okay. Now what I can do is I can assume that this length is B dash. So B dash is from here to here. Okay. I hope you understood, even though my arrows are tilted, right? So in this case, this is B dash and this is B. So you can see this is forming, okay, I did not write the name of the triangle. This is A, this is B, this is C. So this is our obtuse angle triangle ABC. I'll call this D, the height AD, which is equal to H. And this is drawn from the vertex A on base BC. So what do we see here? And I'll name this also wherever this is intersecting, right? I'll call it E, because D we have already taken. So I will take the letter E. So what we see here, A, E, C and D. This is forming a rectangle with length. Length is B plus B dash, right? This whole thing is the length of the rectangle, but the height is H. Right? Or here in the case of rectangle, the breadth is H. So our area will be area of rectangle AECD is equal to B plus B dash into H. So what we see here, this part. Now, if you note here, this AC is the diagonal of this rectangle. And what it is doing, it will be dividing the rectangle into equal halves. Dividing rectangle into equal halves. So this means area of this portion. Let me make it. Let me color it. Right, if you see this area, this triangle, which I have shaded with this green, the area of this triangle, what will it be? The area of triangle ADC, this is equal to half of the area of rectangle. Area of rectangle is B plus B dash into H. Now this ADC, triangle ADC is made up of triangle ADB plus triangle ABC. Now triangle ADC, yes, the bigger one. Now we have found that this is equal to half of B plus B dash H. Now our triangle ADB, if you see, this is also a right angle triangle, right? Because we had drawn a perpendicular from A to the base extension of base BC. So now in this case, what we'll see is triangle ADB area will be, I'll say, half of AD, which is H, into what is DB? Maybe first I should write into AD into dB, right? And I'll call it area of triangle ADB. So should I write here so that taking less space? Okay. Now the other triangle, right? Area of ABC. Now ABC is something which we have to calculate. So we can in fact, okay, first we'll do write it in terms of B and H. So it is going to be half of B dash into H. Now we'll find that area of triangle ABC is equal to area of, I'll write the complete one, area of triangle ADC minus area of triangle ADB, right? You see here, this ADC is the complete shaded portion. Now, if you see from this, if I subtract this part, which I'm now going to shade with blue, right, which I shaded with blue, what did I get? I get the remaining part is the ABC. So in this case, area of triangle ADC was what we got here, this one. So I'll just write it down here. Half of B plus B dash to H, and this is minus, what is the other one? This is the other one, ADB. So I'll write here half of B dash into H. Now I'll take what is the common things, half I'll take out, and then we expand it, multiply B into H, BH plus B dash H minus B dash H, and this is going to give you half of B dash H and B dash H cancel to get B into H. So it's the same thing what we got here when we proved using this one. I drew a perpendicular from B to AC, right? Rather than drawing the perpendicular from A to BC. So that was a simpler one. But if you want something challenging, you can follow this other one also. That is the second method. So this is our area of triangle. So with this, we come to another interesting property, or maybe we can say we can find out or derive a theorem. So we have A, we have B, we have C here. This is our triangle ABC. Now what I'll do is, I'll take the midpoint of BC. This is the midpoint of BC. And I will join A to the midpoint of BC. So if this entire length of the base of the triangle was B, this point I'll call it as D. So now what we can understand is this length is half of B, and similarly this length is half of B. So this becomes B by 2. This becomes B by 2. Okay. Now, first thing is median. What is a median? I said, right? AD is the median of triangle ABC. I hope you have learned what is a median, but I will just repeat it once more. So median is the line segment joining the vertex to the midpoint of the base. So that is actually a median. What I should do actually, okay, anyway, it is fine. Understand, right? Maybe I write here, this is median. And I'll remove it from here. So AD is the median of triangle ABC. Median is the line segment joining the vertex of the triangle to the midpoint of the base. Or we can just say joining the vertex to the midpoint of the opposite side. Okay, so now we have been learning about area. So here also what we are going to do is we will see now how the things are in case we draw a median. How the area looks like if we draw a median. So see here, if I can draw a perpendicular line from A to BC, that is going to be the height h. Okay. And this is parallel to that. So this is also going to be h, right? And this is okay. Yeah. So this is h, and the base is b by 2, b by 2. So now we consider the two triangles. We consider triangle ABD, and we'll consider triangle ACD. Okay, we'll consider these two triangles. What we see here is BD is equal to CD is equal to B by 2, and our height is, we can say height is h, right? So our area of the triangle ABD, area of triangle ABD will be half of base into height. What is the base here? The base is this, which is b by 2. What is the height? Height is this, which is h. So this means this will be half of b by 2 into h. And what will be the area of triangle ACD? This is again going to be base into height. Now what is the base here? The length of base is b by 2. What is the height here? this is a obtuse angle triangle, right? ADC, we can see it is obtuse angle triangle. So either you draw a height from A, or you draw a line parallel. Anyways, it is the same height. We saw in the earlier this proof also, we drew it. We drew the height from A to the extended BC. So same thing if we see here. So it is going to be H. So this is again going to be half of B by 2 into H. So what do we see here? Area of the two triangles are equal. Right? So this gives us our theorem that median of a triangle divides it into two equal triangles, or maybe we can say into, because we are talking about area here, right? Two triangles of equal area. So this is our theorem. Now we'll come to the last thing, at least for this video. It is not the last thing for this chapter, but for this video, we'll close with something which is called Heron's formula. So Heron was a Greek mathematician. Okay? He was a Greek mathematician, and what he gave was that if you suppose don't know the height of the triangle, you just know the length of its sides. So for example, we have this triangle. I know that length is A for this side, length is B for this side, and length is C for this side. I don't know anything about the length of its height. So in this case, what will be the area? How to find out the area? So that is where he derived a formula for this. He came up with a formula for this. The derivation, how that formula came into being, that is outside the scope of your grade for now. So we will just see what that formula actually is. So we have seen the three sides are A, B, C. So what is the perimeter of this triangle? I'll mention here that triangle with sides A, B, C. Sides of length A, B, C. So perimeter we have seen in the last video. If you haven't seen that video, just go and watch it. So this is A, B, C. And then what he did was he made us to take the semi-perimeter. So semi means half. So here what we need to, and we'll call this, we'll name this semi-perimeter as S, small s. So semi-perimeter will be A plus B, B plus C. Move this extra one. Okay, and this is upon, here we'll write 2. So semi-perimeter is half of the perimeter. So here we defined semi-perimeter S is equal to half of A, B, C. So as per Heron, area of the triangle is equal to under root. So I have this under root here. Under root of S into S minus A into S minus B into S minus C. This is the area of the triangle. Now, let's see this in practice, right? We had already seen, right, what the area of a equilateral triangle is. Okay, we did not cover it using the formula we derived earlier. Let's cover it here and see if that is giving us, this Heron's formula and the earlier formula with base and height both give the same answer or not. Okay, so this is your example 3 of the book. I'll just pull it down a little. Okay, so this is a equilateral triangle. I'll call this A, B, and C. And the side of this equilateral triangle is, this side is of unit length. I mean, you can say length is A. And if I'm going to use the first formula, which is half of base into height, I need to draw the height and I'll call it H. So what all we have? Equilateral triangle ABC. AB is equal to BC is equal to CA is equal to A. Because it is an equilateral triangle, all sides are equal. Now we drew a height H from A to BC. Right? H. Now, what do we see here? First, let's see, because this is a equilateral triangle, right? So, equilateral triangle, this height is going to divide it in the base into two equal parts. How do we know that? You see your right angle, this RHS property. So what does RHS congruency says? Right angle, both these triangles are right angle triangle. Then hypotenuse, AB is equal to AC. It is an equilateral triangle. Both are equal in length, A. And then side, this AD is common to both, right? So by RHS congruency, triangle ABD and ADC are congruent. This means BD is equal to CD, right? So I'll write here BD is equal to CD, which means both are equal to half of A. Now what we'll do is, this is a right angle triangle. So I should be able to calculate, or maybe I'll just take one triangle. ADC is right angled. So this means AC square. Okay, where is my square? Yeah. So what I'll do is, okay, so my AC square is equal to hypotenuse square is equal to side squares, sum of the squares of both the sides by Pythagoras theorem. Okay, so this means we know a length of AC, that is A. We know length of DC, it is, or CD, it is A by 2. So this means we can calculate the length of AD, which will mean we have H square will be equal to A square minus A by 2 square, which will be equal to A square minus A square by 4, which is here, this here, it is going to be 4. So this is equal to 4A square minus A square by 4. This is going to be 3A square upon, we have 4. So this means H is going to be under root of 3A square A by, you can say 4, which means it is going to be equal to in under root of 3. Now A square by 4 we can take out of square root, right? So this becomes under root of 3A by 2. This under root is only for 3. So this is the height. So this means our area, what will be the area of triangle ABC will be equal to 1 by half base. Base is A into height is this one, right? This is here, and what I'll do is I'll try to slip. No, let's not try that. Simply go this. Half of base into height. Okay, so this is going to be under root of 3 into A upon 2. So if you multiply it, it is going to come as under root of 3 A square upon 4. This is the area that we got for this equilateral triangle by following our formula of half of base into height. Right? Now we take the other formula from Heron's formula. From Heron's formula, what do we get? Semi-perimeter will be A plus A plus A upon 3, which is, sorry, not 3, semi, right? Semi means it's semi-perimeter, so it is divided by is to 2. So which will make it 3 times A by 2. Okay. Now this is the semi-perimeter, and then I will write the area. So our area will be, we learned S into S minus A into S minus B into S minus C. This is the area of triangle. So this is going to be the root of 3A by 2 into 3A by 2 minus A minus A, and it is going to be the same thing again and again. Let's take this. So you can write it here as, now 3A minus A by 2, what is it? 3, this is going to be 3A minus 2A by 2. This means A by 2, right? So this is going to be 3A by 2, 2 into A by 2, right? 2, and then it is going to be same thing repeated here, same thing repeated. No, I don't know what it did to this, but this is really bad. Okay, into A again by 2, and this is the under root. So what it is coming out as, see, A into A square, A into A square. So it is basically A to the power 4. So our A square will come out of this under root. And then similarly, this is 2 to the power 4. So under root of 2 to the power 4 will be 2 to the power 2. 2 to the power 2 is 4. So we have 4 in the denominator. And then what is left is, which does not have any pair here to take. So we can't take it out of this under root. That is our 3. So we cannot take out 3. Right? So this is like another way of saying this is going to be under root of okay, I'll just take this 3 upon 4 of a square. So what do we see? This one, by the first method also, we got it as under root 3 a square by 4. By Heron's formula also, we got the answer as under root 3 a square by 2. So what does it prove? It will give the area of the triangle. It gave the area of the triangle same in both the cases. So we had proven half of b into h multiple times. So this is when we see the Heron's formula and put it to the equilateral triangle, we see that it is giving the same answer, right? So this means we can use Heron's formula for any triangle where we know the length of its 3 sides, but we don't know the length of its altitude or length or its height. Okay, so that's all for today. That's all for this video. I'll see you in the next video. Till then, keep learning, keep practicing. Bye bye.